All right, so what we've done in past lessons is we've learned all the different forms of lines, and two big features of those lines are where they cross axes and what the slope of the line is, okay? Slope is how the line is tilted. Now, if two lines have the exact same tilt to them and they're separated, they are called parallel, okay? Meaning no matter where you go along them, they're never going to touch, okay? And the feature of that is they have the exact same slope. So if you know the equation of the line, or you can calculate the slope, you can determine whether the lines are truly parallel or not. And just as a little experiment here, I'll show you this. For this red one here, if I find, what you want to do is find two spots that are right on the grid lines, like there and there, okay? And then say, okay, how much do I rise? I rise 1, 2, 3. How much do I run? I run 1, 2, 3, 4, 5, 6. So a rise of 3 over a run of 6 simplifies to a slope of 1/2. Since it simplifies, and in fact dividing by 3, what you can learn from that is that there's actually 3 steps instead of that 1. You could go up 1 over 2. There's another spot right on the grid lines, up 1 over 2, up 1 over 2 like that. Okay, but it's okay if you just pick any 2 and then take the fraction and simplify it. Let's do it down here. Let's take this point right here. If we rise 2, let's say run 4, we've got a rise of 2, run of 4. Simplifying shows you that you have the same slope there of 1/2. So those lines are parallel. Okay. Yeah, that's a big part of this idea. So let's explore what the rest of it has to say here. Okay. Non-vertical lines, if they are vertical, straight up and down, they don't have a number for the slope. So non-vertical lines have the same slope and different y-intercepts. If they had the same y-intercept and the same slope, they'd essentially be the same line, right? You have two equations for the same line. But different intercepts, and same slope. So here, we've got these two lines here. They both have a slope of 1/2, as we just pointed out, and they have different intercepts. This one crosses at +1, this one crosses at -2. Different intercepts, but the same slope means they are parallel, okay? You can use the fact that slopes of parallel lines are the same to write an equation of a line parallel to a given line. So if I said, here's the equation for this line, our line is parallel to it and runs through -2 on the y-axis, we'd know we'd be using the same slope because these are parallel. Okay, let's actually apply this. So a line passes through this point, 12, 5, and it is parallel to this line. What equation represents the line in slope-intercept form? Okay, so we've got the slope. Since it's parallel, we're going to use the same slope. And we know an x and y coordinate. Okay, we've learned a couple of ways of doing it. We can use point-slope form. We could actually do it in slope-intercept form, replacing x with 12, y with 5, m with 2/3, and then solve for b. But how do they do it? They say, okay, first identify the slope. And since the other line has a slope of 2/3, our line has the same. What's next? They're using here point slope form. Y minus y1, there's the y coordinate, equals m parentheses x minus x1, there's the x coordinate. Okay. Distributive property, 2/3 times x is 2/3 x, 2/3 times -12 is -8. So now you've got it in this form so far. Once you simplify it, and the last thing you need to do is add 5 to both sides, and you get this line right here. Okay, so the equation for the line that's parallel to this one and runs through that point is this equation. Okay, and if you wanted to check it, you could actually plug in 12 again for x and 5 for y and just show that it actually works, but you don't need to do that. Now it says y, start with point slope form because you know point and you know the slope. You could also, again, use slope-intercept form, y equals mx plus b, and then say, okay, what if I wanted to, I want to put 2/3 for the slope, x I want to use as 12, y I want to use as 5, because those are the coordinates of the point, plus b, and then you could solve for it. 2/3 of 12 is 8. equals 5 plus b. Subtracting 8 from both sides, we would find that b was equal to -3, just like we have here. So that's another way you could do it that we had actually gone over at one point, okay? Because remember, for y equals mx plus b, there's 4 variables, and if you know 3 of them, and you did know 3 of them, you knew the slope and an x coordinate and a y coordinate, you can solve for the last one. So here's a got it problem for you. Oh, give me a second. See how you do with this. Now you can use the slope to determine whether two lines are perpendicular. This takes a little bit more attention than saying it's exact same slope, so be mindful of this. Notice that if this is a positive slope, this is a negative slope. The idea of perpendicular lines is they come together at 90-degree angles. If you have the axes the same here, right? The same scale for the axes. Otherwise, it might not look the same, but the essential bit of this, if you can't do it visually because of the scale of the axes, is to look at the slopes, and one is going to be the opposite reciprocal of the other. Okay, opposite reciprocals. So two non-vertical lines are perpendicular if the product of their slopes is -1, meaning if you take this slope and you take this slope and you multiply it together, you get -1. Okay, a vertical and a horizontal line will always be perpendicular. Now, since the slope 1/2 times the slope -2, positive times negative is negative, and 1/2 of 2 is 1. We get -1 when we multiply them. The lines are perpendicular, okay? Two numbers whose product is -1 are opposite reciprocals. So the slopes of perpendicular lines are opposite reciprocals. To find the opposite reciprocal of -3/4, for example, first find the reciprocal, flip it, and then write its opposite. Change the sign to its opposite, 4/3, okay? Since -3/4 plus positive 4/3 equals -1, this is the opposite reciprocal. You're going to get good at this quickly. So are the graphs of this line, 4y equals -5x plus 12, and this line, y equals 4/5 x minus 8, are parallel, perpendicular, or neither? So what we need to do really is be able to, we can examine this slope right here, it's 4/5, but what we can't do right now easily is examine this slope. So we need to change this form, okay? Let's see what they say about this, okay? They say, find the slope of each line by writing its equation in slope-intercept form if necessary. Why write each equation in slope-intercept form? Because you can easily identify the slope in an equation that's slope-intercept form. Look for the coefficient of x. So write it in slope-intercept form if needed. This already is. Only the first equation needs to be rewritten. So how do you do it? You can divide both sides by 4 because it already says the y's over here. Slope-intercept form would say y equals something x plus something. And since it's multiplied by 4, we just divide everything by 4 to get it down to y equals. And then -5/4 becomes the coefficient, -5/4 x, and 12 divided by 4 is 3. So when we examine these two slopes, we see this one has a slope of -5/4 right there, and this one has a slope of +4/5. Now it says the slopes are not the same, so they can't be parallel. Multiply them to see if they're opposite reciprocals. Okay, -5/4 times +4/5 becomes -20/20, or -1. The slopes are opposite reciprocals, so the lines are perpendicular. Perpendicular. You can eventually look at these and just be like, yeah, that's obviously opposite sign, and that's flipped. Okay. When it's a little bit more challenging is maybe when one of them's a whole number, so you got to think about it like that, but that will become easy as well. Try this got it problem, both of these, and you're gonna have to change the forms of some of the equations. See how you do with this, and then start it and check. You definitely want to do this practice before you check, or don't just watch it, because if you don't do the practice, it's like watching somebody juggle, right? Seeing somebody juggle is not good enough to learn it yourself, so try it. Here I've done this first one. When we examine the slope, it's already 3/4. When we change this, and you got to be careful to do it right because it's easy to mess it up and get the wrong sign or something, but what do we do here? We subtract 4x from both sides, so we get this rearranged. You keep the negative there. Looks like that, right? So we've got negative 3y equals negative 4x plus 9. Dividing both sides by negative 3, the coefficient in front of y, because you want it to say y equals. What you get is negative over negative. So 4 over 3 becomes positive, right? X minus 3. When we examine these slopes, they are reciprocals, but they are not opposite reciprocals. They have the same sign. So if you multiply them together, you get 1, not negative 1. So they are neither. Neither. Okay, I'll do the next one now. So with this one, the equation here is already written in slope-intercept form. Negative 1/6 is the slope. Here we need to rewrite this one, and essentially we just need to divide everything by 6 because this is 6y instead of y. And that divided by 6, notice that's actually a negative 1 even though you don't see it. So when we put it over 6, when we divide by 6, we have to put that 1 there now. Negative 1/6 x plus 1. Negative 1/6 and negative 1/6, they are parallel, same slope. Okay, here we're identifying in multiple choice which equation represents the line that passes through this and is perpendicular to this. Okay, so first thing we want to do is we say, okay, it's perpendicular, not parallel. So we don't want the same slope. It's not going to be that one. We want the opposite reciprocal slope. And what is the opposite reciprocal of that? Well, if you flip it over, it's 3 over 1, or 3, and we want the opposite sign, so it's negative 3. Right away, we know the slope needs to be negative 3, and we can eliminate that and that as a choice. Okay, the first one has a slope of 1/3. Therefore, we want a slope of negative 3. And then what they do now to figure out which one of these it is, you actually just plug it in. Okay, you use point slope form because we have a point and we have the slope that we know, negative 3, and solve it out. Distribute this through, negative 3x. Negative 3 times negative 2 is positive 6. And when you add 4 to both sides to get that to be y equals, we get this equation right here, which is D. Oops, D. Now, here's your got it problem. Give it a go. It's not a multiple choice, so you got to come up with the answer yourself. All right, an architect is using software to design the ceiling of a room. Okay, this is the existing beam that's there, and the architect needs to enter an equation that represents a new beam. This is all laid out into the graph. My wife's an architect, so I see this kind of stuff all the time on a more complex level, of course. The new beam will be perpendicular to the existing beam, which is represented by the red line. The new beam will pass through the corner represented by the blue point. What is the equation that represents the new beam? Well, what we need to do is two things. Identify what the slope is so we can find the opposite reciprocal, and we need to use that point and that slope in point slope form to find the equation. It doesn't say the equation in slope intercept form. It just says what is an equation. And it could be any equation apparently, because it doesn't specify which type, which means writing it in point slope form should be good enough. Okay, so what do? Use the slope formula to find the slope of the red line. They take a couple of points, 3, 6 right there, right on the grid lines, and 6, 4 also right on the grid lines to calculate the slope as negative 2/3. The slope of the existing beam is negative 2/3, so we want the opposite reciprocal, which is positive 3/2. And then writing the equation says, okay, we know it has to go through point 12, 10, that's that blue point, and have a slope of 3/2. So you can write it in point slope form like that. Since they didn't designate what type of equation they wanted, this would be fine. But in slope intercept form, if you wanted it to look like that, you would distribute that, add the 10 to both sides, and this is the equation you'd come up with. Okay? So What about now? What equation could the architect enter to represent a second beam whose graph will pass through the corner at 0, 10 up here and be parallel to the existing beam? Give your answer in slope-intercept form. Try that and we'll come back in a second. All right, so I've used the point slope form to write this, and what you see is the equation is y equals negative 2/3 x plus 10. We know the slope already was negative 2/3 and our line was parallel to it, so we're using that. Now, notice this, the point they gave us was 0, 10. 0, 10 is actually the y-intercept. So we know the line is going to cross the y-axis at 10, and that's what you're seeing right there. So if you notice that, oh yeah, y-intercepts always have an x-coordinate of 0, you could have said, well, then that's obviously the y-intercept 10, and you could have said, I know it's a slope of negative 2/3, I know what the y-intercept is 10, and you could have written it directly like that if you knew what you were doing, okay? Okay, these are the lesson check problems. The teacher edition answers to these, I'm waiting for access and I will post them on a new video once I get them. Anyhow, you can either do this or you can just work on your homework as practice. Certainly ask questions. Good luck.